Okay, now we're doing section 10.3, and we have to solve using Cramer's rule this system of equations, and there's the strategy. So we find determinants. This means the determinant relative to x. So how do you find that? That equals, we replace the first column with the coefficient, with the results, 5 and -8. And then for the second column, we write down the coefficients on y. And let's find that determinant. And so that equals the product of -3 and 15, or 5, which is -15, and the product of, now it's always minus whatever this product of it is, so minus, a -8 times 3 is going to be a +24, and so that equals 9. Let's find d of y, or d sub y, not d of y. And so now we'll put down the coefficients on x, which are 1 and 2, and in place of the coefficients on y, we'll stick the values of the result. And finding this determinant, the product of 1 and -8 is -8, and minus the product of 2 and 5, so that's -10, and we get -18. So now, so this is d sub x, and this is d sub y. Let's find d. And d equals, and now we'll put down the coefficients on x, which are 1 and 2, and on y, which are 3 and -3. And this equals, the product of 1 and 3 is -3, and minus the product of 2 and 3, which is going to be a -6. And yeah, this equals -9. So now with that done, we can go ahead and solve for x and y. So x equals d sub x, which is 9, over d, which is -9. So x equals -1. And y equals d sub y, which is -18, over d, which is -9. So y equals 2. And so our ordered pair is -1, 2. And when we check those values against each equation, we get true statements in each case. So we did. Well, now we're doing question 3, and you can find the procedure for doing that on page 760. So the issue is this: x equals d sub x over d, y equals d sub y over d, and z equals d sub z over d. So in other words, x is going to equal the determinant of, and replacing the x column with our results, 6, -5, and 14, and then the y column with the coefficients on y, 3, and I guess we have a -1, 1, and -2. And d is simply the determinant of the coefficients on x, y, and z. So that's 1, 3, and x, and 1, -2, and 3, and -1, -2, and, -1, 1, and -2. Now, y, now that we know what d is, it's the determinant of that, and by the way, that should be a 1 there. Yeah. Okay, for y, in the numerator, we'll have the determinant of 1, 3, 1. Now we'll replace the coefficients with y with our results, 6, negative 5, and 14, and then the coefficients on z, 1, negative 1, 1, and negative 2. And rather than write this down again, I'll just put d. And so z equals, and now we've got the coefficients on x, the coefficients on y, and the results in the z column, 6, negative 5, and 14, and we're dividing by d. And so let me solve one of these. Let's just find d, for example. And so d is going to be the determinant of 1, 3, 1, 1, negative 2, 3, and negative 1, 1, and negative 2. And that equals, you know, our cofactor is going to be, the signs on the cofactor go plus, minus, plus, and so on. So plus 1 times, and the minor is the determinant formed by the 2 by 2 involving all the values that are not in the row or column containing the cofactor. So we have negative 2 times negative 2 is 4, minus the product of 3 and 1, which is 3. And now minus times, and the product of negative 2 and 3 is negative 6, and minus the product of 1 and 1, which is negative 1. And now plus a minus 1, so that's going to be a minus, and the product of 3 and 3 is 9, and minus the product of 1 and negative 2, and that'll be 2. So what we have is this difference is 1. This is going to be a negative 7 times a negative 1 is a plus 7, and this is 11, and that's going to be a minus, and 11, and so this equals 8 minus 11 is negative 3. So now we know d is negative 3. So when I evaluated all the other determinants, divided each one by 3, we wound up with x equaling 1, y equaling 3, and z equals negative 2. In other words, our ordered triple is 1, 3, negative 2. And I checked all those values by replacing x, y, and z with 1, 3, and negative 2 respectively, and all statements were true, so we did it right.